Hello guys, today we are going to see how to solve the famous Leetcode problem, which is to sum. We are given an nums array which contains some integer values and the target number integer value. Our task is to return the indices of two numbers such that they add up to the target, which means we have to find the two numbers which the sum of the two numbers which is equal to the target. We don't need to return the number, but we need to return the indices of those numbers. And the question states that each input would have exactly one solution. If we found one solution, we can directly straight away return the solution. And we should not use the same element twice. This is the condition just given in the question. Let's see the example one. Here the target value is 9. The answer output is 0, 1, which means the 2 and 7. If we add 2, 7, it will give 9. Let's see the example here. Here the target value is 9. Let's see sum of the two numbers will give 9. 0, 9. If we add 0, 9, it will give 9. Let's say 1, 8. 1 plus 8 will give 9. Then 2 plus 7, it will also give 9. Like this, we have to find the two numbers which the sum is equal to the target value. Here we can see in the naked eye 2 and 7 will be the two numbers. The indices will be 0, 1, 2, 3, 0, 2. This is the output we have to return. Let's see how to solve this problem in the brute force approach. After this, we can go to the optimal solution. Let's write this question again. I will check this one number with all other numbers. For example, 2 plus 11 will give 13. 2 plus 7 will give 9. We can actually found the answer. The target is 9. We can straight away return 0 and 1, which is the index of these two numbers. Let's take another example. 3, 2, 4. The target is 6. Let's take the first element 3, add with all other elements. 3 plus 2 will give 5. 3 plus 4 will give 7. This is not equal to target. This is not equal to target. So we can't make the target with the element 3. So we move to the next element 2. 2 with the other element 4, 6. 2 plus 4 is equal to 6. We found the answer. We can straight away return the indices of two elements. Let's write the code. I'm going to write the pseudocode of this problem. The function will take two arguments, array and target. We need two for loops to solve this problem. One outer loop for stay in the particular element, then inner loop which is used to check the all other elements with this particular element. For example, outer loop will stay in the element 2, the inner loop will go 11, 7 and 15. Then the outer loop will come here, then inner loop will check 7 and 15, like that. Let's write the code. Let's store the size of the array. For I equal to 0 to n minus 2, the outer loop no need to go till here, it's enough to come here, because we need two elements. If the inner loop will, for j equal to, inner loop will start after the outer loop. If I stays here, j will start from after the ith element. So j equal to I plus 1 to n minus 1. If anywhere the array of I plus array of j equal to target value, we can straight away return I comma j. This is the indices of two element. Whenever the sum of those two elements which is equal to the target, we can straight away return this. We no need to process the other elements. Let's move to the code editor. This is the brute force code for this problem. The I loop will run 0 to n minus 1. Here I mentioned n minus 1 because in Python range function the second argument is excluded, so it will go 0 to n minus 2 only. Then here j loop start from I plus 1 next to I, which ends in n minus 1. Then if I plus nums of I plus nums of j, if the two elements sum is equal to target, we can return it. If I submit the code, the Leetcode will throw time limit exceed. Let's see what is the time complexity and space complexity for this approach. The time complexity will be big O of n square, because we traversing all elements for per element, because for 2 we check all other elements. For 11, then 11 we have check all other elements. For one element we check the possibilities with all other elements. That's why the time complexity is n square, which is not acceptable in Leetcode. But the space complexity is big O of 1. We are not using any more space here. We can move to the optimal solution. Here we will use a map data structure, hash map. Hash map is a special type of data structure which stores the value in key value pairs. We can store element like this 2 1. We can retrieve those elements using the keys. All the keys are unique in map data structure, but the values are not no need to unique. It may duplicates, it may contain duplicate values but not keys, duplicate keys. Let's see how to use the map to solve this problem efficiently. Here I'm going to traverse the array only once at a time. For every element I will store it in the map data structure. Let's see the example 2 11 7 9. I'm going to use the simple math. Here I have 2. I'm going to check what is the other element need to make the target 9. You can definitely say 7. 2 plus 7 will be 9. When I come here, I will check the another element for this target is there in the map or not. If it is there, I can straight away return the indices. Otherwise I will add the element with the index. Let's write the index here. First I will check 2 is there or not. For 2, what is the other element to make 9? 7. 7 is there or not? No, the map data structure is empty. So simply add the element 2 which is in the index 0. Then we can move to the next element 11. Here we have 11. We have to find the other element to make 9, which is obviously minus 2. 11 minus 2 will 9, but there is no minus 2 here. So simply add this current element with the index. Next, move to this element. For 7, what is the other element to make 9? It's obvious, 2. 7 plus 2 will be 9. Check this number is there in the map or not. Yes, we have 2 in the index 2. Index 0. We can straight away return. We found that answer. Current element is 0. The another element is 2, which we already parsed in this array. When we found this, we can straight away return. The element in the map is 0. The current element index is 2, 0, 2. This is what's the optimal one. Let's write the pseudocode for this. Array and value target. I'm going to declare value n to store the how many elements in the array, which means length of the array. Then I'm going to create a map data structure. In Python, we can simply write the curly brace to initialize a map. Here I don't need to write 2 for loops. I need just one for loop to traverse the elements at once. For I2 equal to 0 to n minus 1, when I come to the first element, I will check the complement of this element is there or not. The complement means the another element to make the target. Complement equal to target minus array of I, which is the current element. The complement is the another element which needs to make the target. For example, the current element is 2, the target is 9. Then complement equal to target minus current element, which is 7. To make this number to the target, we need the another element 7. That's all. Then we need to check this complement is there in the map data structure or not. Let's check. If the complement in the map data structure, we can straight away return the index of the element, which is map of array of I. The map data structures hold key value pairs, where the key is the elements and the value is the indexes. When if I have the key, I can get the value. This is the index of the first element which is in the map. Then the another index is I, current index. If it found, we can straight away return this. Otherwise, we can simply add this element to the map of the current element will be I, which is the key will be 2, the value will be the index 0. That's all. Map equal to, declared a new map. Let's write the for loop function. Complement will be a target minus nums of I. If complement in the map, return map of complement comma the current index, or else simply add the current index and value to the map. Maps of nums of I equal to I. That's all. Let's run. Yes. Let's see the time complexity and space complexity of this problem. Time complex will be big O of n, because we are traversing the all elements at most one times. We didn't traverse or accessing the elements twice or thrice. Then the space complexity will be, again it will big O of n, because at the worst case we store these elements to the map data structure. That's why the space complexity is big O of n. Thank you.